Hi friends, in this video we will see RC phase shift oscillator. So it is basically a very low frequency oscillator. So it produces low frequency oscillator and it produces the oscillations in audio range. So audio range only it will produce audio range. So audio range means it is 20 hertz to 20 kilohertz. That's all. So what exactly the feedback network contains? So it is an RC phase shift oscillator. So the feedback network should contain R and C elements. So the feedback network is like this: capacitor, resistor, again a capacitor, again a resistor, and again a capacitor, again a resistor. So this is the structure. Okay, all are RC. RC will be looking like this. So this is the structure. So this is from amplifier output, from amplifier output, and this is to amplifier input, to amplifier input. Okay, so practically we need to reverse this. Okay, so this is capacitor C are there, and this is R. So this is called RC phase shift oscillator. Now we will see here actually three identical RC sections are there. So we need to discuss what exactly each section will do. Okay, that part we will see now. Coming to the explanation of each and every part. So first, as we know, we are having only one capacitor and one resistor. So what it will give? Okay, this is one section, one RC section, excuse me. So this is resistor. What it will give? So first let us analyze this part. So this is the input voltage Vi, and this is voltage across capacitor Vc, and this is the resistor R, and this is V2, and this is capacitor C. So the current will flow like this. This is current I. Okay, so now what how can we deal with this? So let us see with the phasor diagram. Yeah, the phasor diagram contains, let me take current as my reference. If this is the current, so the voltage, I mean current passing through the resistor and the voltage applied across resistor are in phase. So I can say that this part, maybe this part is the I into R, I into R, so which is equal to V2. Okay, this part I am discussing about this part. Now with this actually the voltage is 90-degree lagging with the current for the capacitor. So this is my capacitive voltage, which is Vc is equal to I into Xc. And now if I take the resultant of these two, Vc and V2, so that I will get V1. So my V1 will be like this. So this is my V1 and this is my angle phi, power factor angle. Okay, so now how can we deal with it? So we can deal very easily. Tan phi, yes, so tan phi is equal to tan means opposite side by adjacent side. So what is opposite side? It is V1, sorry, opposite side is Vc, because see, if this is opposite side, this one and this one are same. Okay, so opposite side will be Vc, so I can write Vc divided by adjacent side will be V2, which is equal to, what is Vc? Vc means I into Xc and V2 means I into R. So if I will get cancelled, it will come around Xc by R. Very simple. So now using Xc is equal to 1 by omega c, what I can write? I can write tan phi is equal to, okay, 1 by 2 pi omega c into r. Okay, so this is the tan phi value. So how to deal with it? So with this, the values of R and C are selected. Okay, so that it should give a phase shift of 60 degree. Okay, that means here phi should be constant. It is 60. So go ahead with the tan 60. So how much value will come? You have to substitute here, and then you have to play the things with R and C, so that you have to select the corresponding values of R and C, so that the phase shift should be 60 degree. If one thing will give the 60 degree, if one branch will give the 60 degree, then other two branches will again give 60 60 60, which implies, so 3 into 60 degrees, so it will be equal to 180 degree, and our amplifier itself will give us 180 degree. So finally it will be theta equal to 360 degree. So now I can say that I can use this particular phase shift, RC phase shift network, as an oscillator. Okay, so this is the main concept of RC phase shift oscillator. Let us see what are the merits and demerits of RC phase shift oscillator. So these things are very very important for any competitive examination, and also for the main examination point of view. They may ask one question such that compare the oscillators, okay, and with merits and demerits. So based on merits and demerits only, you have to compare the oscillators. Okay, what are the merits and demerits of RC oscillator? What are the merits and demerits of LC oscillator? What are the merits and demerits of crystal oscillators? If you compare these things, then that question will be solved. Okay, so coming to merits and demerits of our LC oscillator. So the first point will be the circuit is simple and easy to design. So obviously it should be there. The circuit is simple and easy to design. Easy to design. So this point is very simple because it is giving us very less frequency only. The circuit is less bulky, lightweight, and less expensive due to absence of inductor. So it is less bulky, less weight, less bulky, less weight, and less expensive. Less expensive. That's all. This is these things, these very good things we are obtaining because of lack of inductor. As in our circuit there is no inductor, so it is lightweight, and it's not bulky, and also it's not expensive. So let's move on to the third point. It can be used to generate oscillations in audio frequency range. So if you want audio frequency range, then this is the best circuit for generating audio frequency signals. And one more thing is, it generates sinusoidal signals, sinusoidal oscillations. As it is producing sinusoidal oscillations, so it is very easy for us to analyze. I mean, we can take these oscillations and we can give it to some other circuits also, because they are in sinusoidal in nature. So many circuits are designed for sinusoidal signals, so we can easily use for them. So these are the some of the merits of RC phase shift oscillator. Now let's move on to the demerits of RC phase shift oscillator. So the demerits are, it has a very low quality factor. It has a very low quality factor. Because why? If it is low quality factor, what will happen? Because of this frequency drift, when circuit parameters vary due to aging and temperature. So for example, the circuit parameters may vary with aging and temperature. That means if we are keep on using the same type of elements, maybe resistors or capacitors, if we keep on using for the long time, so definitely they will deteriorate their value, and their value will be changing, the parameters value will be changing. So because of these things, if on top of that, if your system is with low quality factor, what will happen? definitely your system is low quality factor, and your elements are also aging. Because of aging, it is giving wrong value. So what will happen? So because of this, our frequency is drifting. That means we are getting some other frequencies. Okay, so this is the problem with low quality factor. So obviously it has pure stability. So it has pure stability. It has a poor frequency stability. Frequency stability. Okay, and the third point will be, so to generate high frequencies, so what's required? The required feedback network capacitance becomes too small, so we have to make them very small, which will be comparable with the stray capacitances. Hence it has no marked advantage over LC oscillators. Okay, so that's why it has a very less efficiency, I mean very less opportunity of getting high frequencies. So what will happen if it go to high frequencies means, if we use it for high frequency, the capacitors in this value, the capacitors in our RC network will be very less, which are comparable with stray capacitances. That means stray capacitances means the capacitance which is generally available with the wires and all those things. Okay, stray capacitance, that means very less. So these things are also very less. So obviously whatever the value we are willing to get it, we are unable to get it. Okay, so because of this, it is somewhat inferior compared to LC oscillators for high frequency is concerned. Coming to the fourth point, so we can go ahead with variable frequency operation also. And for this, what we have to do, we have to change three capacitors simultaneously, such that impedance, okay, beta, a beta, and hence amplitude of the oscillations kept constant. So everything we need to keep constant, and we need to change capacitors only. So this is not that much easy, because for a wide range of frequency ranges, it is not that much easy. For example, if I want to change for only one frequency, I can easily go ahead with that. If I change it for next frequency, I can go. But within short time, I like to go ahead with too many frequencies, it's very difficult for me to change capacitors for each and every frequency. So this is the disadvantage of RC phase shift oscillator. So variable frequency, for getting variable frequency, what I have to do, I have to change all capacitors, keeping all parameters constant. That means A should be constant, beta should be constant, A beta should be constant. Okay, but if you want to do it frequently, it is very much difficult. Okay, so these are the merits and demerits of RC phase shift oscillator. So thank you so much for your careful listening. If you have any more doubts, you can put it in the comment window so that I can answer your queries. Thank you so much.